All right, so we're on to part C, and part C is about the unit circle. Oh my gosh, I really wish we had so much more time because I would have made you make your circle sons, and we don't have time for that though. Circle sons are so fun. I will show you some examples of circle sons. Give me here. So these are unit circle sons. Aren't they beautiful? We don't have time to, but we would. It helps you remember, it helps you learn. It's about fold, it's creating the folds. Look how cute they are. Like, yes. But we're just gonna be lame and just write it down on our notes. Okay. Aww. I know we're so lame this year, but you do need to memorize it. Okay, this unit circle will need to be memorized. It will need to become your best friend for the remainder of this course. And if you plan to go into AP calculus or taking any calculus or physics in college, it will still need to be somewhere in your brain. Okay. Good luck. Go be great. So here we go. First, we're going to start off with the geometry connection. The unit circle is based off of geometry, right? Trigonometry is based off of geometry. And it comes from using your special right triangles. So when we look up here, there were two special right triangles that you should have left geometry like hardcore knowing. 30, 60, 90, 45, 45, 90. Yes? Somewhat? Okay. All right. We'll take that. So when you have your triangles, what makes them special is that unlike most triangles where you have to know two sides, with 30, 60, 90s and 45, 45, 90s, you only have to know one side in order to calculate the rest. That's because they fall under a ratio of each other, okay? There's a ratio that you use to get from one triangle to the next. Does that make sense? Does that ring a bell? Sounds about right. There's a ratio that follows to get from one triangle to the next. So how does that ratio work? So no matter what, if they are a unit circle, if it's a 30, 60, 90, regardless of the size, this is going to be your 1x. This is going to be whatever 1 times this number. Okay, this is your, does anyone remember the relationship between it's your 2x. The hypotenuse is double. And then this is going to be x square root of 3. So if I know any side, then I can solve for every side. Does that make sense? I just need to know one. Because once I have that x value, I can calculate the rest of my side. Okay. Your x is always across from your 30. Your 2x is always across from your 90. And your x is always across from x squared root of 3 is always across from 60. So how I remember this is, I know it's going to sound weird. It doesn't make sense to you, but it's 1, 2, square root of 3. Say it with me. 1, 2, square root of 3. And this is my 30, my 90, my 60. Don't do that. Okay? 1, 2, square root of 3. 1, 2, square root of 3. And that's the ratio of relation, the ratio to each side. Okay? So that's our 30, 60, 90. Now we're going to do our 45, 45, 90. For the 45, 45, 90, it is an isosceles right triangle, correct? Isosceles right triangle means that two of your sides are the same. So two of my sides are the same. So their relationship here is it's 1x, 1x, and then this is going to be x square root of 2. Because when I take the Pythagorean theorem and I solve for that side, it becomes 1 plus 1, which is 2. And then I take the square root of 2, which gives me x, gives me square root of 2. Okay? Yes? So this one is 1, 1, square root of 2. 1, 1, square root of 2. And that's how you remember their ratio of sides. Questions about 30, 60, 90? Do y'all remember these things? I'm not making them up. Huh? Okay. All right. Your teacher may not have sung a song or anything, but the gist should be there, right? Not for geometry. All right. So here we go. Values. So when we look at this, this becomes helpful because we can use the same concept here for analyzing any triangle, but it's not necessary, especially once we have it drawn on a unit circle. What makes the unit circle our friend and so much easier to utilize is that we remind ourselves of the relationship between our right triangles led us to these conclusions. Now, instead of talking about hypotenuse, leg, adjacent leg, opposite leg. We now can talk of things in terms of X's, Y's, and R's. Yes? Does that make sense? So we can describe things in terms of X, Y, and R. And describing things in terms of X, Y, and R helps us calculate our sine and cosine with sine, cosine, and tangent without use of a calculator. So for example here, we talked about, I'm pretty sure, on Tuesday. What's today? Whatever the last day I saw you. That sine theta equals your y divided by your r. Do you all remember taking that connection? Yes? Okay. And then we talked about cosine theta equals your x divided by your r. And that your tan theta equals your y divided by your x. So refreshing that, from based on what we have here, our r is 1. Our x is square root of 3 over 2. And our y is 1/2. Do I have everything I need in order to calculate? Your radius? Do we have everything we need to calculate all 3 trig values? Yes. So I'm going to start off with y over r. So we have 1/2 divided by 1, which is just going to be what? That's an ugly 2. 1/2. Anything divided by 1 is its self. I respect that. Okay. Next, we have square root of 3 divided by 2 divided by 1, which is just going to be square root of 3 over 2. Lastly, we have y divided by x. So we have 1/2 divided by the square root of 3 over 2. How do I evaluate? We keep, change, flip. So we're going to multiply the numerator by the reciprocal of the denominator. That's essentially what you're doing. That's what you're doing mathematically. But we remember it as K, C, F. We're going to keep. We're going to change from division to multiplication, and we're going to flip our denominator. And like August said, our 2's are going to cancel out, and we're left with 1 over the square root of 3. What did we learn a couple of days ago about that? We can't have a radical in the denominator. Don't put baby in the corner, okay? Which part? I kept the numerator the same. I changed from division to multiplication, and I reciprocated the denominator. Okay. All right. So we're going to multiply numerator and denominator by our radical, and we get square root of 3 over 3. Okay. So the conclusion here is that we notice, what do you notice about the sine and cosine compared to the x and y values? They did what? Yeah. Did they change? No, they stayed the same. The reason why they stayed the same is because your radius is 1. Okay. So when your radius / your hypotenuse, I think I spelled that right, equals 1. Therefore, your x and y is going to always represent your cosine and your sine. You should have space at the very bottom of your page, right? You have a whole white space at the bottom. Whoa. I don't have time for this bullying today. Yes.
When you how'd you get square root of 3 over 3?
What's 3 times 3? What's square root of 3? There you go.
Oh, so the square root times 3.
And that's exactly what it does.
So you can't. Would that be like 2 times the square root of 3?
No. 2 times square root of 3 comes from adding square root of 3 plus square root of 3. That means you have 2 square root of 3.
Oh, yeah. You're squaring it.
Yes.
Okay.
All right. Okay, so to make sure that we understand this, I would like for you to try number 10. Do number 10. Yes. Oh, I'm sorry. I forgot to label that this, our theta is 30 degrees. Sorry. So after doing this and talking about it, and we understand that when the radius or the hypotenuse equals 1, that your x and y is your cosine theta and your sine theta. I would like for you to take a moment to do 10 and 11, and then we'll come back together, okay? So at your groups, you're going to do 10 and 11, find the sine, cosine, and tangent. So for number 10, you're finding the sine, cosine, and tangent for 45 degrees. For number 11, you're finding the sine, cosine, and tangent for 60 degrees. Okay? All right, go. Go back again? Yes. No, you're fine. Okay, let's see how we did for 45 degrees. So this is telling you that theta is 45 degrees. So this is a 45-degree angle, okay? These are the coordinates at a 45-degree angle. Square root of 2 over 2, square root of 2 over 2. So this is your x, and this is your y, and this is your r. Based on the previous problem that we did, we talked about that when your radius is 1, your sine theta is just whatever your y is. So my sine theta is square root of 2 over 2. Your cosine theta is whatever your x is. My x is square root of 2 over 2. And that's because my radius is 1. Does that make sense? All right. Tan theta equals your y divided by your x. So square root of 2 divided by 2, square root of 2 divided by 2. That is not a 2. Don't even know how I made that into a 4. I think I just saw a bunch of 2s and said, 4 must be next. Anything divided by itself is 1.
You got that? Let me see a little.
No.
I think you're not a little up in
Nope. Your radius is not half of your x and y. That's not the ratio.
That's making sense because the radius is from the center to the edge of the circle.
It's from the center to the edge, but it's not half of your x and y value. They don't go all the way to the edge.
Yeah, half of the diameter.
Yeah, but where are you getting diameter from?
The radius is half the diameter.
Yes. No, these are just axes. They're not diameters. That's why it goes on forever.
So
The center of the circle is made by the intersection of your axes, but your axes aren't your diameter or your radius. Okay, so that was for 45. Now we're going to go on to 60. So for a 60-degree angle, we're now a little further up on this unit circle. Remember, a unit circle is called a unit circle because the radius is 1, a unit. That's why it's called a unit circle. Okay, so your radius is automatically 1. And our theta here now is 60 degrees. Because our unit is 1, when we're looking for our sine theta, it's going to automatically be the y coordinate, which is square root of 3 over 2. When we're looking for cosine theta, it's going to automatically be the x coordinate. So it's going to be 1/2. Our tan theta equals y divided by x. So our y divided by our x would be square root of 3 over 2 divided by 1/2. When you divide fractions, you keep, change, and flip. So I'm just going to be left with square root of 3. The 2's will cancel out, and I'll just be left with square root of 3. Okay? These are the main sine, cosine, and tangent values you have to know. The 30, the 45, the 60. Okay? The 30, the 45, and 60 are the main ones that we need to know. Then the rest are called our quadrantals. So our first quadrantal we're going to look at is going to be 90 degrees. So 90 degrees is a little bit of a unique spot, right? So if I have a 90-degree angle, that means I'm going from here to here, right? That's my theta, and it equals 90 degrees. Yep, it is. Okay, I'm on a unit circle. Because it's a unit circle, that means that the furthest out from the origin is only 1 unit. So here's my center, and I'm going to go 1 unit out. So this now is at point 0, 1. Does that make sense? Because this one would be at point 1, 0, because it's just a unit. So I've only gone 1 unit from the center of the circle because the radius is 1. All right, so with that being said, because the radius is 1, I can say that the sine of 90 equals, well, what is the y value at 90 degrees? What is the y value at 90 degrees? 1. The y value at 90 degrees is 1. Cosine of 90 would be the x value. What is the x value at 90 degrees? X value at 90 degrees. 0. The x value at 90 degrees is 0. Your tan theta, so the tan of 90, is still going to be y divided by x. So y is 1 and x is 0. Oh no, that's not possible. It's undefined. Okay, remember it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. I'm sorry? The 0, because if I'm at the origin and I go 1 unit up, I went 0 units left or right, and I went 1 unit up. Yep.
So you use radius as 1.
I said we're using the radius is 1. So if my radius is 1, that means from the center, I'm going only 1 unit to the right, which would be where my initial site is, right? And then I'm going 1 unit up, which was me at 0, 1. I was telling you for this problem, our radius is 1. Yeah. For a unit circle, because we're drawing on a unit circle. And again, a unit circle means your radius is a unit, which means 1.
So what was the p?
Huh?
On the other column, the p and then it goes to x and y value. What would that be?
It says P, our P is 0, 1. 1, 0 was where I was saying, because this is a unit circle, to figure out where we're going, I'm going to go 1 unit to the right, 1 unit to the left. So this is where my initial site is. And then I had to go 90 degrees, which means I'm going to stop here. This makes it 90 degrees, right? And so therefore going 1 unit straight up means my P is at 0, 1. All right, so the conclusion, huh? No. The conclusion here is that when you have a radius of 1, so when you have a radius equal to 1, the sine of theta is equal to the y coordinate. Okay? The cosine of theta is equal to the x coordinate. And the tangent is the ratio of your x and y coordinate. Of your y divided by y chord and x chord. I did not leave enough space for that, so we're just going to abbreviate. Essentially, it's just y divided by x. If it exists. And what you just saw, did it exist for 90? No, it was undefined because there was a 0 in our denominator. All right, so we're going to make this into a beautiful table that puts everything together. Here you go. So tying it all together, these are our what we call our reference angles for our unit circle. Okay, they're called our reference angle for our unit circle, meaning that in every quadrant, I can use these to figure out the sine, cosine, and tangent of the angles that are that amount from the x-axis. So we'll dive a little deeper into that. But first, summarizing for sine of 30 degrees, which is equivalent to pi over 6, what did we get? What was our sine? Yeah, we're summarizing what we've learned. What is the sine? No. Pi over 6 is the equivalent radian value. What is the sine of 30 degrees? Yeah, look in our notes. 1/2. It's going to always be 1/2. Yeah, we did it. Right here. When we were at our 30 degrees, sine of the theta was 1/2. It's going to tell you 0.5 every single time. No, this is now, because of this pattern, this is if you have an angle of 30 degrees, regardless of your radius, you're going to get 1/2.
Put it in degree mode, right?
Or you can put it in pi over 6 in radian mode because they're equivalent. Okay? Using the unit circle help them recognize the pattern of the angles. Like, what is the angle? I can have a 30-degree angle and it could be super long, right? But that sine of that angle isn't going to change. Okay? All right, cosine of 30 degrees. Look in your notes. We're summarizing what we've learned. Square root of 3 divided by 2. The tan of 30 degrees. Square root of 3 over 3. So any angle, no matter how long it is, no matter how long the radius is, if it's an angle that is 30 degrees, this is its sine, cosine, and tangent. Does that make sense? No matter what the radius is. Okay, now we're going to do 45. 45 degrees equals pi over 4 radius. What is the sine of 45 degrees? Square root of 2 over 2. What is the cosine of 30 degrees? No, 45 degrees, sorry. Square root of 2 divided by 2. And what is the tan of 45 degrees? 1. So any angle that is 45 degrees or pi over 4, these are its sine, cosine, and tan values. Excuse me? Okay, sine of 60. So sine of 60 is what? Square root of 3 divided by 2. Cosine of 60, 1/2, and tan of 60. Square root of 3. So any angle that is 60 degrees or pi over 3, these are the values that it's going to be. They do not change. They are what they are. They are constant. All right. Now we're going to talk about our quadrantals. We're going to fill in a chart like this for our quadrantal angles. Quadrantal angles are your angles that make up your quadrants. Quadrantal? Well, they're called quadrantal angles, okay? Your quadrantal angles are as you rotate around, counting 90 degrees. Does that make sense? Because each quarter turn is 90 degrees. So we start at 0. 0 plus 90 puts us at 90. 90 plus 90 puts us at 180. 180 plus 90 puts us at 270. And then 270 plus 90 brings us back to 360. Did I lose anyone there? Because this is a unit circle, as I was telling you, that means that its points at its minimum points that we focus on are at 1, 0, 0, 1, -1, 0, and 0, -1. And that's because this is representing a unit circle. Yes? Okay, so taking our degrees and put them in terms of radians. So in terms of radians, I took 2 pi and divided it into 4 parts. Yes? So it's 0, pi over 2, pi, and 3 pi over 2. Those are my equivalent radian values. So now we're going to do sine. Remember, sine is your X. I'm sorry, sine is not your X. Sine is your Y. You saw nothing. You heard nothing. Sine is our Y coordinate. Cosine is our X coordinate. And tan is Y divided by X. So we're going to go through each one of these and fill them in appropriately. Got it? So sine of 0, 0. Cosine of 0, tan of 0. Tan of 0 is 0. Because 0 would be in the numerator, right? Okay, let's do 90. 90, sine of 90. 1. Cosine of 90. Tan of 90. Define. Sine of 180. Why is it probably 0? What is the Y coordinate at 180 degrees? 0. Cosine of 180. And then tan of 180. 0. Because it's 0 divided by -1. Okay, now we're at 3 pi over 2. For 3 pi over 2, what is the sine of 0? I mean, sine of 3 pi over 2? -1. Cosine of 3 pi over 2? 0. Tan of 3 pi over 2? Undefined. Okay, I'm going to go ahead and write this in. 0 degrees is the same as 360 degrees, which is the same as 2 pi. That's why we do not have a column for 360 and 2 pi.
Wait. Same thing for 360.
360 degrees equals 2 pi.
Oh, so you're saying it's the same?
I'm saying their sine, cosine, and tangent are the same. Yes. We just don't have a third row because you're coming back around. Does that make sense? Okay, so we have now created the foundation for our unit circle. Yes, the foundation for our unit circle has been created. All right, be mindful as you're moving through and you're rotating which way you're going. It's going to be positive when I go counterclockwise. It's going to be negative when I go clockwise. Okay, so here we go. We're going to put everything in place on the unit circle. Yeah. You will have, no, you have to memorize this. This is something you have to memorize. We will start having weekly unit circle quizzes. Yes. You have to memorize. Yes. We have weekly unit circle quizzes. Until the test. Yes.
Hey.
No, until the test.
You're gonna have these.
Yes.
Is it just a quiz of filling the unit?
Yes. Okay. Until it becomes your best friend. Yes. It is a grade. It is a grade.
Can we do one of these fracture projects?
Oh no, maybe. You want to make a unit circle Sunday?
Yeah, I want to make a unit circle soon.
All right, so here we go. Unit circle. So I was kind enough to give you all your radians already, right? So we're going to go in and write in the degrees that correspond to the radians. Does that make sense? So we're going to go in and write in the degrees that correspond to the radians. So at 0, it's obviously 0 degrees. Okay. Oh, y'all need a highlighter. Does it? You need 3 highlighters. Trust the process.
Wait, why are we putting degrees?
Or just something different color. Huh? You have to know the equivalent degrees. So we're putting in the degrees.
Wait, but that's important.
We're going to put in the coordinates. We're putting in the degrees first. It's everything. You will not be given the radians. You will not be given the degrees. You will need to fill it in completely blank. Oh my gosh. think y'all have been the most complaining class about this that I've had to teach.
I think it's a self-esteem thing.
I don't know what it is. All right. So just other color pens work as well. But we're going to go in and write the angles in degrees. So obviously 0 is 0 degrees. I don't need to write that, correct? Okay. So pi over 6 is 30 degrees. Pi over 4, that was 45 degrees. Pi over 3 is 60 degrees, correct? Pi over 2 is 90. Pi was 180. 3 pi over 2 is 270. And 2 pi is 360. Now you're probably wondering, what about the rest of these angles? Not a lot, just a little bit. All right, so to find these angles, what we're going to do is use their reference angle. So when I said you needed a highlighter, this is why. So reference angles are the angles in quadrant 1 that help you figure out the values in sines of every angle in all the other quadrants. Does that make sense? So my reference angle that we're going to first highlight is going to be 30 degrees. So 30 degrees is going to be my first highlight. From 30 degrees, I'm going to highlight just for the sake of knowing where I'm highlighting, the first point from every x-axis. So I'm highlighting 5 pi over 6. I'm highlighting 7 pi over 6. I'm highlighting 11 pi over 6. The reason why I did that is because each one of these are 30 degrees away from their nearest x-axis. So if I know that this is 180, that means that 5 pi over 6 equals 150. Do we see that? Okay, if I know that this is a 30 degree, 180 plus 30 is going to tell me what 7 pi over 6 is. 210. Do we see that? Okay. And then 360 minus this would be 330. That's what it means by a reference angle. Yes? Now we're going to do 45s. So my 45s, again, let me go to my highlighter. I'm going to get green. So now we're going to do 45s. So 45s, 45s, or a different color pen. So they're going to be 45 degrees from the nearest x-axis. Notice I'm saying x-axis, right? So 45 degrees from my nearest x-axis. So 180 minus 45 puts me at what? If you have $180 and you spent $45, what are you left with? 135. Okay. If you have 180 plus 45, you're going to be where? 225. If you have 360 minus 45, 315. Do we see how important that 30, 45, 60 is right now? Okay. And then our last reference angle is going to be our 60. Again, if you can do this with pen, it's just one. And we're going to go, pew. And then we're going to go, pew. And then we're going to go, pew. Okay. So now we're asking us to be 60 degrees from our nearest x-axis. So 60 degrees from less than 180 puts us where? 120. 60 degrees more than 180 puts us at 240. And 60 degrees less than 360 puts us at 300. Okay. Do you see how we filled in the angles knowing what we know? Yes. Okay. The beauty of also this is it helps you fill in your radians as well. Okay. So for your radians, It's already written for you, but let's talk about how they work. So notice that at 30, it's counting by pi over 6, right? So at 30, it's counting by pi over 6. So if I'm counting to all the places that are multiples of 30 or factors of 30, I'm going to count by sixes. So that means for me, I'm counting, this is 1 6, this is 2 6, 3 6, 4 6, 5 6, 7 6. Does that mean 6 6? I'm sorry, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, and then 12 out of 6. So I went 1 6, 2 6, 3 6, 4 6, 5 6, 7 6, because 45 is not it's not part of it, right? It's not a multiple of 30. Yeah. What was that? 5, 6, 7, 8, 9, 10, 11, 12. All they are reduced forms of 6. Okay? 45s are reduced forms of 4s. So pi over 4 is 1 4, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, and 8 fourths. Yes.
For example, pi over 3 is equivalent to 2 pi over 6.
Mm-hmm. Yep. Exactly. So you can fill in all just by counting by pi over 6 and pi over 4 in their correct locations. You can also fill in your pies. Our first quiz will be just to see how it goes on Tuesday. No, our test is next Thursday.
That's pretty great.
Next week's quiz will probably just be a unit circle quiz. All right, so your ordered pairs. All of your ordered pairs, again, it's based off of quadrant 1. So filling in quadrant 1 is how do I hide this? Is the most important piece. Okay. That's because after you fill in quadrant 1, everything else falls into place. Okay. So for quadrant 1, we're going to start here. So 0, our ordered pairs are 1 and 0. Because I'm 1 unit away from the center, correct? The rest depend on what are our cosine and sine values of those angles. So at 30, if you open your chart really quick, what is the cosine and sine of 30? Cosine and sine of 30. And the sine is 1/2. At 45, what is the cosine and sine of 45? There you go. At 60, what is the cosine and sine of 60? Perfect. And then for 90, what was our sine and cosine? It was 0, 1. Okay. So how this works is that each quadrant has rules to follow. In quadrant 1, we are positive x's and positive y's, right? In quadrant 2, we are negative x's and positive y's. In quadrant 3, we are negative x's and negative y's. And in quadrant 4, we are
They're all the same.
exactly. Exactly. Oh my gosh. What? Yes. You don't say. That's crazy. They align with the highlighters. That's, oh my goodness. Are we done being big babies about it? Yes. Yes. All right, here we go. So if you're looking at the 30-degree reference angles, so your 30-degree reference angles are going to be the same as 30 in quadrant one, but you have to pay attention to the signs. Does that make sense? So in quadrant two, my x has to be what? Negative. So it's going to be square root of 3 over 2 and 1/2. In quadrant three, they both have to be negative. So it's going to be negative square root of 3 over 2 and negative 1/2. And quadrant four, my x is positive and my y is negative. Ta-da! So terrible. Okay, you fill in the rest. Go. All right, so our most important quadrant is quadrant one then. What's our most important quadrant to know? One. Because if you know quadrant one, then you know everything. Okay, all of it. Cool? All right, last little piece here. Scroll on down. Is tying it all together. So, every function has a reciprocal function. So sine, its reciprocal function is called cosecant. Cosine, its reciprocal function is called secant. And tangent, its reciprocal function is called cotangent. All this means is that if sine is y, then cosecant is 1 over y. Okay? If exactly, and secant would be 1 over x. And if tangent is y over x, then cotangent is x over y. They are reciprocal functions, which means that I'm reciprocating their ratio. Does that make sense? Okay. In quadrant one, everyone is positive. You're positive, you're positive, you're positive. In quadrant two, the only thing that is positive is sine. Everything else is negative. In quadrant three, sine and cosine are negative, and tangent is positive because a negative times a negative makes a positive. Makes sense?
Yes.
And then in quadrant four, you have a negative y, positive x, which means that your tan has to be negative. So how my teacher taught us to remember this is all students take calculus. All are positive in quadrant one. Only sine and its reciprocal are positive in quadrant two. Only tangent and its reciprocal are positive in quadrant three. And only cosine and its reciprocal are positive in quadrant four. I will get there momentarily. All students take calculus. It's how you should appropriately remember it. Okay,